Welcome to the lecture on problem solving on Monte Carlo simulation. So, in the last lecture we discussed about how to solve the problem using Monte Carlo, and in this lecture also we will practice on some more questions, so that we have even better understanding how to simulate the different kinds of problems which can encounter, and we can use the generation of random numbers, and then we can predict the measures of performances. So, as we discussed that in the Monte Carlo simulation, basically you need to have the probability distribution or basically the probability values for certain outcomes for any particular parameter or variable. Now, in that case, if you are given the probability, so you will find the cumulative probabilities, and then you will map the random numbers generated, which are basically uniformly distributed random numbers, between two numbers, and then accordingly you are taking the numbers and solving the problems. Now, as we discussed that many a times you can have the generation of random numbers automatically by suitable programs, and many a times you may use the different kinds of generation of random numbers using certain algorithm like congruential generators. So, how you can use some method of congruential generator, and how can you use that random numbers which are generated by these congruential generators, and you can use them for the solution of any problem. So, let us deal with a problem where we will use the congruential generator, that is mixed congruential generator, first to find the random numbers, and then that random number is basically used for solving the problem. Many a times you will have the random numbers given that you can use these sets. Anyway, those numbers also are the distributed random numbers uniformly, and that also is generated with certain algorithm, certain method. So, if the problem is given like you predict certain measures of performance and use certain type of generator to find the random numbers, based on that you can predict, you can take the values, and then you can find the measures of performances. So, let us deal with one such problem which is related to the number of vehicles available and unit produced. So, the problem is like this, that you have unit produced, that is x, and then you have also number of vehicles available. So, in a plant the units which are produced in the manufacturing facility, that is given, and based on that at a particular station what is the number of vehicle available, that is having certain correlation. Now, unit produced also in the plant has certain probability that can follow certain probability distribution, but then here the probability is given like if it is given that you have 500, 550, 600, 650 and 700. So, suppose the probability of finding these, having these many units produced is given as suppose 6%, so 0.06, then it is given that this is 14%, 0.14, 20%, so 20, 40%, so 40, and again 0.20. So, it is given that the probability that x is xi. So, this is basically xi, you can say, and probability that x equal to xi is given as this. Similarly, the number of vehicles which are available are basically given that also ranges to 5, 6, 7, 8 and 9. So, this is 5, then you have 6, 7, 8 and 9. So, basically if you have the unit produced 500 and you have the number of vehicles which is available is 5. Similarly, on 550 it is 6, 7, 8 and 9. Now, for that also there is some probability. So, if suppose this is yi and this is the random variable y. So, probability of y equal to yi. So, that value is again given and this is given as 0.16. So, 16%, then you have 0.36, 36%, 0.20, then you have 0.16 and 0.12. So, this is given that this is the probability. Now, in this case you are told that you should generate. So, the random numbers you should assign that what will be the random number, and once the random number comes, but for that particular random number, how can you say that this time you have the number of vehicles available is 5 or 6 or 7, like that. So, now the thing is that they are telling that you generate the random variates or random numbers using the mixed congruential generator. So, to generate random numbers between 0 and 100. So, excluding 100 basically. So, from 0 to 99 basically that will be more correct, from 00 to 99 using mixed congruential generator. So, mixed congruential generator you have to find. So, you have to find suppose u1 here and you have to find u2 here. Now, the thing is that if the u1 is, now you can see that if the u1 value is from 00 to 05, in that case you have this value as 500. So, units which are produced are 500, because looking at this cumulative distribution you can see that if you have the random number between 0 to basically 05. So, 0, 1, 2, 3, 4, 5, there are 6 random numbers which if you are getting, you are basically assigning the units produced as 500. So, since this cumulative probability will be 20 here, so it will be from 06 to 19. So, there are 14 entities in between. Similarly, from, so it will be 20. So, then again 22, this is 40, so 39. So, that number if comes, you will have the basically number unit produced as 600. So, similarly, then 40 to 79 and 80 to 99. So, if the u1 is in this range, you are going to take the unit produced as 500. Now, similarly, so this tells that you have to generate the random number from 00 to 99. So, if you are taking the mixed congruential generator, in the mixed congruential generator we have 3 parameters. One is A, 3 constants basically A, C and M. A is the basically the in constant, and so that is multiplier basically A into xi minus 1 or x 0 for finding the next number x1, and then you have the addition of C, that is a constant, and then you have modulus of m. So, m is not m will be basically 100, because you have to get the remainder. So, you have to get up to 99. Now, similarly in the case of u2, you will have number, if you take random number which is will be valid for finding these values, will be 0 0 to 1 5, then 16 to, so this is 52. So, 16 plus 36 is 52. So, it will be 51. Similarly, you have 52. So, this is 72, cumulative value is 72 here. So, it will be 71, then 72 to 80, so 88, so 87 will be there, and then 88 to 99. So, this way you are generating these, you are assigning the random numbers if they come on the way, and then how can you assign these numbers for getting a particular unit produced, or for getting the number of vehicles which are available at a particular iteration. So, now how to generate these random numbers for that. So, for u1 they have given that you should have A as 21, C as 3 and M as 100 and x naught or x 0 as 20. And similarly for u2 they have given that the condition is given like this. So, for u2 condition is A as 41, C as 7, M as again 100, because we have to generate between below 100. So, from 00 to 99, and then the seed value is taken as 1. Now, suppose this is how it is given. So, in that case you can generate the numbers. So, if you have, so first of all if you go for this, you will have x naught as, basically you will have x naught as given as 20, then x1. So, what will be x1? x1 will be A into x naught. So, this is 21 into 20, 420 plus 3, 423 mod 100. So, it will be 423 mod 100. So, that is why it is 23. Then x2. Now, x2 will be now taking 23. So, 23 into 21. So, that is 483 plus 3, 486. So, it is 486 mod 100. So, this is coming as 86. Similarly, x3 will be 86 multiplied by 21. So, that is 1806 plus 3, 1809, and that being taken mod by 100. So, it will be 09. Similarly, x4 will be 09 multiplied by 21, 189 plus 3, 192. So, it will be 192 mod 100, it will be 92. Then you have x5 as 92 multiplied by 21. So, that is 1932 plus 3, 1935, 1935 mod of 100, that is 35. x6 will be 35 again multiplied by 21. So, 735 plus 3, 38. x7 38 multiplied by again 21, it will be 798 plus 3. So, that is 801. So, 801 mod 100, that is 1. So, that becomes 1. Then you have x8. So, this way x8 comes. Then if you generate further 1 into 21, that is 21 plus 3 24. So, that will be 24. Further it will be 24 into 21, that is 504, and plus 3 507. So, it will be 7. So, this way you will have the numbers coming, you have 10 numbers generated from x 0 to x 9. So, this is how you can generate the numbers for even u2. Now, for u2, if you look at, you have x 0 given as 1, x 1 becomes 1 into 41 and plus 7 mod of 100. So, 48 mod 100, so that is 48. X 2, 48 multiplied by 41. So, that will be 1968 and plus 7. So, that will be 1975. So, that will be 1975 mod 100. So, that will be 75. Again 75 mod of 41. So, that will be 3075 and 3075 plus 7. So, that will be 3082, and that further mod of 100. So, it will be 82. X 4, 82 multiplied by 41. So, that will be basically 3362 plus 7 3369. So, it will be 69. X 5 will be 69 multiplied by 41. So, that will be 2829 plus 7 2836. So, it will be 36. X 6 will be 36 multiplied by 41, that will be 1476 plus 7 1483. So, it will be 1483 mod 100 83. Similarly, x 7 will be 83 multiplied by 41. So, it will be 3403 plus 7 3410. So, it will be 10. X 8 will be 10 multiplied by 41, 410 plus 7 417. So, it will be 17, and x 9 will be 17 multiplied by 41 697 plus 7, that is 704. So, you get 704 mod 100, that will be 04. So, this is how you can generate the random numbers. You know that in this case you will have a maximum period of 100 random numbers, because you have the period of 100. So, once any number comes, in that case that will further a cycle will be generated. But here we have not seen that stage has come, and we feel that this is so. Anyway, these numbers require to be tested for uniformity and dependence, but then that is a separate issue that can be done. Now, we can do the simulation. So, let us see, we will take these numbers in order. Now, we have the table. So, you have the day number. So, you will have the simulation now. So, simulation will be day number, day will be 1 2 3. Then you will have the random number for unit production. Similarly, you will have unit produced according to that number. Then you have further random number for vehicle availability, VA. Similarly, you will have number of vehicle available. So, now let us see, we have the random numbers starting from 20. So, first of all, day 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Suppose you have to do the simulation for 10 days. In that case, you can see like this. In the first case, random number for unit produced will be 20, 23, 86. So, this is 20, 23, 86. then you have 9, 92, 35, 9, 92 and 35. Similarly 38, 1 and 24, 38, 1 and 24, and then you have 7. Now against these numbers, if you compare from here, so 20 comes in this, so 20 will, so here you will have unit produce 600. 23 also comes here, so 600. 86 comes here, so 700. 9 comes in the second row, that is 550. 92 will be here, so that will be 700. 35 will be here, that is 600. 38 will be again here 600. 01 will be in this 500. 24 will be in this range, so 600. And 7, so 7 will be in this in that second one, so that will be 550. Similarly, random number for the vehicle availability. Now random number for vehicle availability is as 148.75, then 82.69.36, 83.10.17 and 04. So for 01 it is 5 days, 5 number of vehicles. For 48 it is here, so it is 6. For 75 it is here 8. For 82 it is 8. For 69 it is 7. For 36 it is 6. For 83 it will be 8. For 10, so for 10 it will be here 5. For 17 it will be again 6. For 4 it will be 5. So like that you have to generate. So the purpose was to make you aware that how you have to generate the different. Now there may be another method, you may be told to generate using the mid square method. So in the mid square method you are told some number, and then further you have to go and take the middle of the numbers. So that can be done, but in that case it's not, we are not sure that what will be the and how many numbers you can get in continuation, so that you have to check it. Now in many such congruential generators, you know that how you can achieve the maximum period. So that is basically, there are certain rules that we had discussed. So this way, if you see the total number of unit produced, if you add them, it's coming around 6,000. Yes, so it is 6,000. Similarly, if you add them, number of vehicles which are available, so 11, 19, 27, 7, 34, 6, 40, 48, 53, then 59 plus 5, 64. So what we see is the average number of unit produced is basically 6,000 here, and that if you take the average unit, it will be 6,000 by 10, that is 600. Similarly, average number of vehicles which are available, that will be 64 and divided by 10, so that will be 6.4. So this you can basically find. And similarly, if you have the other data given, like what is the total capacity which it can accommodate, that way the production plant, so you can have different tables, and from there you can have the shortages, what is expected, like that, and then you can find all these measures of performances in such problems. So it all depends that you must understand how to generate these random numbers using those methods. You can generate using the uniform distribution method by using the generator like Excel, by using programs, by using the softwares like Arena, Input Analyzer or so. So, you can have the generation of numbers and you can have all these values mapped into and predict the measures of performances. We can further deal with another question where which is like this, that you have a teller window and in that the probability of inter-arrival time is given. So, inter-arrival time in minutes is given. So, and its probability is also given. So, if it is from varying from 5 to 8. So, 5, 6, 7 and 8, and its probability is coming out to be 0.15, 0.35, 0.35 and 0.15. So, suppose it is this type of distribution function where you have 0.15 on the side and then it is coming like 0.35, 0.35 and 0.15. Similarly, you have the service time. So, then service time is given and then that is given as, and its probability is also given. So, service time varies from 5 to 7. So, 5, 6 and 7, and in that case its probability is 0.25, 0.50 and 0.25, and you can generate the random numbers for this also, but here the numbers are given and this is random number u1 is given for this as 25, 37, 91, 00, 61, 62, 80, 15 and 23. Similarly, for this the random number is given as 84, 01, 59, 40, 03, 29, 50, 77 and 32. So, suppose this is given, we know that the numbers which will be assigned for 5, we can do it from here itself. So, as we know that you will have the random numbers for the range will be, we can write here just or in the bracket we can write. Here the space is less, so we can write in the brackets itself random numbers which will be assigned falling in this. Similarly, you will have random numbers. So, as you see that this is 15.15, so 00 to 14. Similarly, you will have 15 to 34 and 35 to 69. No, there is a mistake. Here it will be 14, 152, it will be 35 numbers. So, it is 50. So, 49. Then it will be 50 to 85. So, 50 to 84. 50 to 84 and then 85 to 99. Similarly, in this case you will have 00 to 24, 25 to 74, 75 to 99. So, this way the random number you can assign and then you can see that how. So, the random numbers will be coming and accordingly you can assign. So, the random number for the inter-arrival time, and that is seen as 25, 37, 37, 91, 00, 61, 62, 80, 15 and 23. So, these are the numbers which are given, suppose, and then you have for this you can have the inter-arrival time. So, you can have for this the what is the inter-arrival time? Arrival time you can write from here. So, inter-arrival time will be for 25, suppose it is coming in this, so it will be 6. So, this way 6, 6, 8, 5, then you will have 77766. So, this way you can just see any number like 15. So, for 15 it is here, so it is 6, then for 62 it is 7, like that. Similarly, so random, so it will be arrival time. So, arrival will be at what time? Arrival at. So, you can simply write 12, 20, it will be, you have to add them. So, this will be 20, 25, 32, 39, 46, 52 and 58. Next we will go beyond 760. So, we have to go for 1 hour simulation, that is why we are stopping here. Then in that case you will have the random number for departure service. So, for service, as you know, we have 840159, then you have 400329, and then we have 5077 and 32. So, for that again you can see the service time. Service time will be further written, and service time will be for 84, it will be 7. So, similarly you will have other numbers you can write. So, this will be 5665, then further you will have 6676. So, this way you will have those service time. Now, you can find the time of departure. So, departure time you can find. Now, this person comes at 6 and his service time is 7. So, he will depart at 13. So, this person comes at 12, but this person departs at 13. So, he will depart at 18 because he has 5 minutes of service time. Then he is coming at 20. So, anyway the server will be free for that time, and this 20 will come and go at 26. Now, at 26 he will have to wait for 1 minute. So, 26 plus 6 32. Now, this 32 is same. So, it will be 37, 37 here again 39. So, 2 minutes is the waiting, server is waiting. So, 39 plus 6 45, similarly 46 plus 6 52, then you will have 59, and then you will have 65. So, 65 anyway it is going. So, it is going beyond the 60 minutes. So, we are stopping here. So, this way now you can find from here whatever you have to calculate, that how much is the waiting time of the server, what is the utilization of the server percentage, all these can be found out. So, what we see that you can use the different methods of generating random numbers. These methods could have been generated by any congruential generators or by any other type of random variate generators using any typical distribution or so, and you can solve such methods, solve problems and gain more and more confidence. So, this is the end of this last lecture of this course. I hope that you have enjoyed this course, and I wish you a very good luck for those who are appearing for the exams of this course. Thank you very much.